Now we want to talk about how we would find the area of this region, because I didn't do an area. Usually people do an area first, but I've already done areas. If I want the area, then I come back to this little rectangle here, and ask myself, what's the area of that little rectangle? Well, the area of that little rectangle is just delta x by delta y. So what would we be summing up as we partition this x strip and partition the strip and then run over all such x strips, strips of width delta x? We're just going to be adding up delta x times delta y, so our integral is just going to be the integral of dy dx or dx dy. Okay? Using the first description, the outer integral needs to be the one that represents x, because it has the constant limits. So the outer integral is with respect to x, the inner integral is with respect to y, and we use this description. The limits, in other words, will be exactly the same as they were here. It's just that we're not integrating an altitude. We're not getting a volume, so we don't need an altitude. We just take the plain old area, which is going to be our delta x, delta y, or delta y, delta x, and in the limit that's going to just give us our dy dx. We just do that integral. And if we use the other description, we're going to use this, and again we're just going to integrate dx dy in this case, because in these descriptions y has the constant bounds. So y goes from 0 to 4, so we integrate from 0 to 4 with respect to y. What do we integrate? We integrate from negative square root of, what in the world? Yeah, I mean, it's got to be y, but it looks a whole lot like 4. Make it look a little more like y. Negative square root of y to y, because between y equals 0 and 4, these are our limits. And then we add the integral from 4 to 8, because between 4 and 8 our limits go from here to here. So y goes from 4 to 8. X goes, I wrote it down wrong here. It's dx. I mean, this has to be y out here because it's y, it has the constant limits. It's got to be dx dy. So again, we integrate from here to here with respect to x, and then whatever expression we get out of that, we integrate from 4 to 8 with respect to y. Gives us our area. Okay, again, the difference between these integrals and these integrals is that in these integrals, we use the sample point to get the altitude of our three-dimensional region, and our integral then adds up all those altitudes as delta x, delta y go to 0. For the area, we don't have an altitude, we just have an area. The area of this thing is dx dy, delta x, delta y. That's where we get the dy dx or the dx dy.